Hey, welcome. This is task 5.8, guess my parallelogram. So it's all about some of the properties of parallelograms. Given certain clues, we're going to try and say what type of parallelogram it is. We're going to try and be as specific as we can. So for example, a square is more specific than a parallelogram, which is more specific than a quadrilateral, right? So let's see what we got. So the first one, it says the diagonals are perpendicular to each other, and it's a parallelogram. Again, we note that for a parallelogram, the diagonals bisect each other. So this will be bisected into two segments, and this will be bisected into two segments. And one of the things that you notice is that this creates four congruent triangles that have, because they all have side angle side. They got the 90-degree angle, and they've got the two sides. So given that these are four congruent triangles, we can say that the base of these triangles is the same. And the fact that we have four congruent sides, this means that it has to be a rhombus. All right. The next one is consecutive angles are supplementary, that they add up to 180, right? Well, if you look at a pair of consecutive angles, the fact that they add up to 180, that means that these sides must be parallel because there's 180 degrees between those. It could also be true if you looked at a different pair of consecutive angles right next to each other. Again, this is enough to say that these sides must be also parallel. And that's the definition of a parallelogram, is that opposite sides are parallel. So we can say this would work for any parallelogram. The next one is the diagonals are congruent. Well, one of the things that we know is that all parallelograms bisect each other, the diagonals. So if they are congruent, that means that all four of these segments are also congruent. So we've got some isosceles triangles. We've got an isosceles triangle here where both of these angles are congruent. And then it's the same, because this vertical angle here, the one on the other side is the same isosceles triangle. So maybe this is angle 1, angle 1, angle 1, and angle 1. Then on the other side, we've got another isosceles. This could be angle 2 as well as here, angle 2. So every one of these vertices is really the sum of measure of angle 1 plus the measure of angle 2. So they must all be congruent, all of these angles. And if they're all congruent and all four of them have a measure of 360 degrees, that means that they're all right angles. They're all right. And so that is the definition of a rectangle. It's a quadrilateral with four right angles. Then there's this one with the rotation. You can kind of picture in the red where it's rotated. In order for it to superimpose on top of each other, like this side here gets moved over here. So that means that these two sides are the same. It also means, if you're doing a 90-degree rotation, that you have a 90-degree angle. So if that is true, then you've got four 90-degree angles, and you're going to end up with four sides that are congruent. And that is definition of a square, has four congruent sides and four right angles. So this one has to be a square. The next one is if the consecutive angles, so the ones next to each other, if they're congruent, well, if they're all congruent, the measure this here, 4 times the measure of any of these angles, let's just call it A, it's going to be equal to 360 degrees. That's the angle sum for a quadrilateral. So therefore, the measure of each of these angles is going to be equal to 90 degrees. The definition of 4 90-degree angles, the definition of the parallelogram that meets that is a rectangle. Okay, and the last one, the diagonals are congruent and perpendicular to each other. This is really a combination of the first one, the diagonals are perpendicular. This was a rhombus. And the third one, which is the diagonals are congruent, it's a parallelogram. So this one is both, or not a parallel, it was a rectangle. So this one is both a rectangle, but it's also a rhombus. In other words, it's got the 4 right angles, and it's got 4 congruent sides. So therefore, there's only one thing that works there, and that is the square.